All right, today, guys, I'm going to go over 1.6 homework part 2. It's pages 46 to 47, 32 to 64 even, 65, 66, and 67. This is going to use a lot of complex conjugates. We're going to go over combining like terms. We're going to go over how to plot the numbers on a complex plane, which is kind of like graphing. We'll go over absolute value. So everything, and we'll kind of go over some other stuff from there. But it's going to be a little bit quicker than the first one, not as much solving. So the hardest part about this is going to be complex conjugates, where everybody struggles the most. So pay attention on that. We're going to go from there. All right, so on number 32, I have 7 plus 4i over 2 minus 3i. Sometimes they instead of saying simplifying, they're talking about dividing complex numbers. So I'm saying the complex number 7 plus 4i divided by the complex number 2 minus 3i. We just have to remember you cannot have a radical in the bottom. That's what we learned in 1.5. So that means, remember, I is a fancy way to say the square root of negative 1. So if you can't have an I in the bottom, you can't have a radical in the bottom, you can't have an I in the bottom. And that's when we use our conjugate box. So if you guys remember, we had a conjugate box. All right. So now what I'm going to do is I'm going to look at 2 minus 3i. I'm going to say, is it going to be easy or is it going to be hard? And I look at it, and to me, it's going to be hard. So it looks like a minus bi, so I'm going to use a plus bi. So I see 2 minus 3i, so all I do is I change the sign in the middle. That's his, remember, conjugate soulmate. I pretend conjugates are like soulmates. It's the only number in the universe that I can multiply together that makes the I disappear. Now, on the top, remember, we talked about the top and bottom. This box has to equal 1. So that's why the top and bottom have to be exactly the same. So that's our first step in here. Now, what I'm going to do is I'm going to put 7 plus 4i, because when you multiply, you just multiply across the top. All over whatever's on the bottom. Now, the top you have to FOIL. You have to FOIL the top. Remember, I don't call it FOIL, I call it distributive property, but either way, you have to FOIL the top. The bottom, you can FOIL, or I'm going to use my shortcut. All right. So the bottom, if you guys see here, our shortcut, it says that our shortcut says take the first number, a, and square it. Take the second number, not the I part, just the 3, and square it and add them together. So that's going to be the bottom is just 4 plus 9. If you FOIL it, you'll get the same thing. Now, for the top, I'm going to FOIL. So 7 is going to go over to 2, give me 14. Then 7 is going to go over to 3i. It's going to give me 21i. Now, 4i is going to go over to 2 to give me 8i. And then 4i is going to go over to 3i to give me 12i squared. I'm going to rewrite that a little bit. It's not turning out very nicely. So it's going to give me 4i goes over to 2, gives me 8i. Oh, it's weird there. And then 4 times 3 is 12, and I times I is I squared. So it's going to be plus 12i squared. Now then we got to remember that anytime I squared shows up, it changes that to minus 12. So I squared is negative 1. It's on the bottom left of our hint page. So it makes the positive 12 negative 12. And now I just put my real friends with my real friends and my imaginary friends with my imaginary friends. So I'm going to look through here. I'm going to put 14 with minus 12. So that's going to turn into 2. Now I'm going to do 21i and 8i together is 21i, 29i. And the bottom is 13. You could leave it just like that. Sometimes, if you go further, like if you were to look it up or on like an ACT, they actually like to split the fraction. So they make it 2 over 13 plus 29 over 13i. That's the best answer really right here, best answer. But I am totally okay with that answer. Either way is fine with me. All right, so 34, 36, 38, and 40, they're all plotting complex numbers. So remember, this is just a number line. Even though this is a graph, right, from our back when we used to have this line back when we were graphing would be the x-axis. Now this is going to be our real number line. So that's just the number 1, 2, 3, 4, 5, 6, etc., etc., etc. Remember, if you don't write anything, that means you're counting by ones. Now the up and down, that used to be y, now it's i's. So this is I, 2i, 3i. Not showing up very good. Let's pick a different number, different color. Let's try that. I, 2i, 3i, etc. And this would be negative I, negative 2i, negative 3i. So when I do the real part is left and right. So this part is left and right. You go right if it's positive, left if it's negative. This part is up and down. So to get 34, I'm going to go right 1, up 2. So I'm going to go right 1, up 2. I put a dot there. Boom. And that's how I'm going to label. I'm just put 34 right there. Now 36 is negative 6. That means I just go down 6. 1, 2, 3, 4, 5, 6. That's it. That's all we're doing for plotting. That's it. And I'm put a 36 right there so you know it's 36. 38, I'm going to go left 7. And I'm going to go down 1i. And then 40, I'm just going to go up 7. Or I'm going to go right 7. That's it. That's the entire section. All right, the next section is finding absolute value. Remember, that would be like the distance on our number line from 0. So like if we made that, if you imagine what we did on the last couple of problems where we made those dots on the grid, on the complex plane, if I measured the distance from the origin to that dot, that's what this is. And it uses Pythagorean theorem. So all we're going to use is this formula right here. So this is A, and this is B. Look, I don't use the I. All right? So to find the absolute value, all I'm going to do, so and they use these bars. So to say the absolute value of 4 plus 3i, the bars mean absolute value, equals the square root, well, A is 4, so it's 4 squared, plus B, which is 3 squared. That's it. Now I have the absolute value of 4 plus 3i equals the square root, well, 4 squared is 16, 3 squared is 9. So the absolute value of 4 plus 3i. So the left side is like, this is just like a label. It's like saying x equals. It's just a label. So I end up with the square root of 25. Now remember, we learned in 1.5 that 25 is perfect. So the absolute value of 4 plus 3i is actually just 5. So that's it for 42. 44, the exact same concept. So 44 is the exact same concept. I have 10 minus 7i. So once again, I want the absolute value of 10 minus 7i. And it's not a parentheses, it's a bar. That's A, that's B. Now, a lot of times, you guys make calculator mistakes when you include the negative. So because it's absolute value, and absolute value is always positive and real, you can literally just ignore the minus sign. You can just say A is 10 and B is 7. So I don't even worry about the minus sign, I don't worry about the I. So I have the absolute value of 10 minus 7i equals the square root of 100 plus 49. So I have the absolute value of 10 minus 7i equals the square root of 149. Now, you do have to make sure that this can't be broken down using our perfect squares like we did on section 1.5, because we can't forget everything we learned. And this one cannot. So that is, we're done here. All right? So that's it. This is the best answer. 46, the exact same concept. All right? 46 is find the absolute value of negative 8i. So remember, I'm going to say the absolute value. That's why the bars are outside of it. The absolute value of negative 8i equals, now there is no a, so a is 0 squared, And look, I'm going to ignore the negative. I'm going to ignore the I. I'm just going to put 8 squared. So I end up with the absolute value of negative 8i equals the square root of 64. So that means the absolute value of negative 8i is just equal to 8. And that should make sense. Like if you made your grid and you went down 8, it's really easy to count 8 units to the origin. So that should make sense. So 48, the exact same concept. So 48 is negative 4 plus I. Actually, 48 people make mistakes because there's not a number in front of the I. Remember, there's always a 1 there if you don't remember that. Math guys don't really write that down. So we have the absolute value of negative 4 plus I. So now, remember, the absolute value of negative 4 plus I, this is your A. So this is A, and but B is actually the 1 in front of it. So I have the square root of 4 squared plus 1 squared. So the absolute value of negative 4 plus I is equal to 16 plus 1. The absolute value of negative 4 plus I equals the square root of 17. So that's it. The keyword is springtime. The keyword is springtime. Now 50 says, what is the absolute value of 9 plus 12i? So we have the absolute value of 9 plus 12i. Even though it's a multiple choice question, I still need to see work. So if you don't do any work, you're not going to get credit. So you're going to show me that this is A and this is B. So I have the absolute value, that's what the bars mean. So this is like your label, equals the square root of 9 squared plus 12 squared. So look, then I say the absolute value of 9 plus 12i, that's just my label, equals the square root of 81 plus 144. Well, 81 plus 144 is 225. And I know that the square root of 225, that is perfect. So the absolute value of 9 plus 12i is just 15. So it's not always a radical number. Sometimes the radical works out nicely. Sometimes we have to finish and continue to reduce the radical or simplify the radical like we've done in section 1.5. All right, 52, 54, 56 is all simplifying. So you have to, these are all multi-step problems where you have to kind of put together everything in the entire section that we've done. 52 is pretty easy because it's all addition. So there is no FOIL in 52. No FOIL. So the parentheses just go away. So I'm left with just 3 plus 2i plus 5 minus I, because look, that plus sign means nothing changes here. Somebody's going to mess up and make both these positive. Do not do that. Now all I do is I put my real friends with my real friends and my imaginary friends with my imaginary friends. So 3 goes with 5, so it's going to be 8. Now I'm going to do 2i minus I plus 6i. 2i minus I is I plus 6i is 7i. So your best answer should be 8 plus 7i. And that's it for 52. All right, 54 has 3 sets of parentheses. Remember, you can only FOIL 2 at a time. So I'm going to pick the first 2. So what I'm going to do first is I'm going to only focus on these 2 right here. I'm not even going to look at the last set of parentheses, and I'm going to FOIL. So I'm going to take 1 over to 1. I'm going to get 1. I'm going to take 1 over to minus 4i. I'm going to get minus 4i. Now, I'm going to take negative 9i over to 1. I'm going to get minus 9i. I'm going to take negative 9i over to negative 4i. I'm going to get plus 36i squared. And then I remember that 36i squared, that I squared is negative 1. So this becomes minus 36. So my first 2 sets of parentheses turn into 1 minus 36 is negative 35. Minus 4i minus 9i is minus 13i. So these 2 parentheses turn into this set of parentheses. I haven't done anything with 4 minus 3i, so I just put that right there. Now I'm going to FOIL again. So I'm going to FOIL. Negative 35 is going to go to 4. So negative 35 times 4 is negative 140. Negative 35 goes over to negative 3i. So negative 35 goes over to negative 3i. It becomes plus, because it's a negative times a negative, 105i. Now, negative 13 is going to go over to 4. Negative 13i is going to go over to 4. So I do negative 13 times 4. I end up with negative 52i. Now I'm going to do negative 13 times negative 3. It's going to be plus 39i squared. And then I have to remember that 39 turns into negative 39 because I squared is negative 1. So now I put my real friends with my real friends. Negative 140 minus 39 is negative 179. 105i minus 52i is plus 53i. And that's it for 54. 56 might be the hardest problem up to this point in this homework, just because it puts a lot of stuff together at one time. So you're gonna do a lot of different things, and then you're gonna eventually have to make conjugates show up. But I'm gonna do the top first. And remember, the negative goes to both of these. So this is actually going to become a negative 3 and a positive 2i. So I'm going to subtract, because remember, when you subtract, you have to subtract both of them. Somebody's going to mess up and forget to change negative 2i to positive 2i. So I do 10 minus 3 to get 7. And then I do 4i plus 2i to get 6i. All right? That's the top. Now the bottom is FOIL. This is FOIL. So 6 is going to go over to 1. I'm just going to put the work underneath it to save myself some space. 6. Then I'm going to get 6 times negative 2i is minus 12i. Now I'm going to do negative 7i times 1 is minus 7i. Now negative 7i times minus 2 is plus 14i squared. Remember, the I squared right here makes this negative 14. So the bottom of this after FOIL actually turns into 6 minus 14, which is negative 8. Then I have minus 12i, minus 7i is minus 19i. Now, that's just doing the beginning part of this. If we were allowed to have an I on the bottom, we'd be done. But we're not allowed to have an I on the bottom, so remember that's where my conjugate comes up. Now, these are complex conjugates, and these are hard conjugates. I think they're hard. So my bottom, remember, the conjugate pair, the soulmate for this guy, is the only thing we do is we change the sign in the middle. So the biggest mistake I see here is somebody makes the 8 positive when it has to stay negative. So notice, look, I left negative 8 the same. I just changed the sign to 19. I put plus in the middle. I have to do the top exactly the same. Remember, the top and bottom have to do the same. So this whole problem turns into 7 plus 6i. And in parentheses, I'm going to have negative 8 plus 19i. Now the bottom is negative 8 minus 19i in the first set of parentheses. And then negative 8 plus 19i in the second set of parentheses. Now we have to FOIL the top and we have to FOIL the bottom. So FOIL the top, FOIL the bottom. So just like I did on the bottom part. So I'm doing this is why this problem is difficult, because it's a whole bunch of, it's not anything different. It's just you have to do it a whole bunch of times. So I'm going to end up with the top is going to be negative 56. Now I do 7 times 19. And the other reason it's hard because they give you kind of odd numbers and bigger numbers. So 7 times 19 is 133i. Now I'm going to do the inside. 6i goes to negative 8. That becomes minus 48i. And now 6i goes to 19i. So 6 times 19 is 114. It's positive because it's a positive times a positive, and it's I squared. Now remember, I'm going to use my shortcut for this. So I'm going to take negative 8. I'm going to square it to get 64. I'm going to take 19. I'm going to square it to get 361. So then look, our shortcut says to add them. And 19 squared is 361. So, after all of this, we're going to continue. We're going to start simplifying. The I squared makes 114. negative 114. On the top, I put my real parts together. So I do negative 56 minus 114. I end up with negative 170. On the bottom, then I'm going to do my imaginary parts. 133 minus 48 is 85. So I have 85i. The bottom is 64 plus 361. 425. Now, if you left it like this, you would get you would at most lose it. Like this is a good answer. But it can be simplified because all three of those are divisible by at least 5, right? Really, they're divisible by a much bigger number than that. So what I'm going to do is I'm going to kind of break, I call it splitting the fraction. So what I'm going to do here is I'm going to split this fraction. I'm going to put negative 170 over 425, and I'm going to put 85i over 425. So we do got a little bit more work to do. So what I'm going to do is I'm going to do negative 170 all over 425, and then it's plus, so this I did, and then I'm going to do 85i, but it's 85 all over 425, and then I. Because Mathland, they like to have the purple part is the real part, the green part is the imaginary part, and then the red part, or the green part is the coefficient for the imaginary part, and the red part is I. So now, now you're going to simplify the fraction. So I do negative 170, ABC, 425. I get negative 2/5. So both of these are all of these are divisible by 85 actually. So all three of these numbers, this number, and this number, all divided by 85. So this is a great answer, but the best answer, the overall best answer, is going to be negative 2/5 plus 1/5 I. That's the 100% best answer, and that's pretty tough. I think that one's pretty tough. I don't think you'll see anything that hard on a quiz. All right, 58. I'm going to do 58 right next to it, so I'm going to do 58, and we're going to see where they went wrong. So remember, this is A, this is B. We're using our absolute value. So I'm going to say that the absolute value of 2 minus 3i is equal to, remember that's our label, and I'm going to take A, which is 2. I'm going to take B, so it's plus, and I'm going to put B. You can either put negative 3 in parentheses if you're going to use the negative and square it, or just ignore the negative altogether. So that's what they forgot to do. See how they didn't put that negative in the parentheses? Because that's going to change things. Because remember, absolute value cannot be negative. Absolute value is distance. Distance is always real. Distance is always positive. So really what should have happened is they should have got, oh, I forgot my little 2. They should have got 2 squared, which is 4, plus negative 3 squared, which is 9. So actually the absolute value of 2 minus 3i should have been the square root of 13. And that's it for 58. All right, so number 60 says, find 2 imaginary numbers of your choice that when you add them together, they equal a real number. For example, let's say I had 3 plus 7i. Now, if I add that to another imaginary number, let's say I say 17 plus 6i. If I add those together, I end up with 20 plus 23i. So I have an imaginary number plus an imaginary number equals an imaginary number. Not going to help me. But if I had 3 plus 7i and I decide to add, I don't know, 12, but this time I'm going to look at that and make it 7i. When I add those two together, 3 and 12 is 15, but this time 7i minus 7i is 0. Look, that's a real number. That's a real number. So basically, how are they related? The imaginary numbers must be opposite. That's it. Believe it or not, 62 and 64 are not incredibly difficult. They're just awkward because they don't have any numbers involved. We know that if we have an I on the bottom, our conjugate box has to show up. And we know that the soulmate, the conjugate soulmate, is always the opposite. So I take and I make it C plus DI, and whatever I do over there, C plus DI. Now I'm going to write them as one big fraction, which I usually don't do if I'm trying to save space. But if you are struggling, put it as one big fraction. You're going to FOIL the top, and you're going to FOIL the bottom, or you're going to use your shortcut. So I already know the bottom is going to be really easy. So I know the bottom is going to be, I'm going to take C, I'm going to square it. I'm going to take D, I'm going to square it, and I'm going to add them together. Now the top's going to be a little more difficult. So look, I'm going to go A goes to C, so that's AC. A goes to DI, that's ADI. Now negative BI goes to C, so that's minus BCI. And negative BI goes to D, so that's minus BDI squared. And then we had to remember that I squared makes the whole thing there positive, so it's plus BD. So really, my best answer, and there's a bunch of different ways that they might write this, is I'm going to put AC plus BD. Then I'm going to add it. These two are like terms. So it's going to be AD minus BC, but with I, all over C squared plus D squared. All right. Basically, I'm just saying, like, this little piece right here is just saying I would take this piece minus this piece and then put I next to it, like if they were numbers. So that's it. That's all I wanted you to do, is just leave it in terms of numbers. All right, so 64 is almost the exact same as 62. So remember, I look at the bottom. We're not allowed to have an I on the bottom. That's where our conjugate box comes into play. Remember, I look at the bottom, I just change the sign in the middle. It's the only thing I change. So even though this is a difficult looking problem, and it's awkward because there are no numbers involved, it's still the same exact concept. So remember, I'm going to make the top one big fraction bar. So the top is going to be A minus BI in one set of parentheses. And then the next set of parentheses, I'm going to have C minus DI. I'm going to FOIL that. The bottom is going to become C plus DI in one set of parentheses. And then in the other set of parentheses, C minus DI. Now, once again, the bottom is super easy because I'm just going to use the shortcut. I'm not even going to FOIL the bottom. The shortcut says take the first thing, C, square it. Take the next number, D, square it, put a plus sign in the middle. Now, what gets hard is when we try to FOIL all these letters, that's where everybody gets stuck. So A goes over to C, so that's AC. A goes over to minus DI, becomes minus ADI. Now, negative BI goes over to C, becomes minus BCI. And then finally, BI negative goes over to negative DI, so it's a positive BDI squared. And then we got to remember I squared is -1, so it becomes minus BD. So nothing has changed concept-wise. It just got really awkward and messy because they're all letters. So I know to finish this, I'm going to put AC minus BD. Then I'm actually going to, they both are being subtracted, so I'm going to subtract AD and BC all with an I. And the whole thing is over C squared plus D squared. And that's it. So like you don't have to get some nice answer at the end. All right, 65, 66, and 67, really, really easy once you understand the concept. All you're going to do is identify what's the resistor, what's the inductor, what's the capacitor. You're going to apply the impedance, which is in the chart below, and then you're just going to combine everything. So 65, right? So the resistor is going to be this symbol. So this is the resistor, which means 4 ohms is the first resistor. And look, with impedance, we don't change resistor. It just stays the same. Now, I'm going to look at an inductor. An inductor is that little squiggly line. So 6 ohms and 65 is the inductor. So it says whatever your resistance is for, or reactance for your inductor, you add an I for the impedance. So it's plus 6I. Now, lastly, we got to find a capacitor. This is the capacitor symbol, right? So I take 9i, I put plus 9, but really it's going to say, remember it says minus, so you're going to make it the opposite and add the I, so I'm going to minus 9i. So all I'm going to do to make sure that this is correct is I'm going to combine my like terms. So I have 4, because there's no other real parts, 6i minus 9i is minus 3i, and then I add the word ohms because that's the label. That's it. So 66, 14 is the resistance. 7 is the inductor, which means we make it plus 7i. And then 8 is the capacitor, which makes it minus 8i. So I'm going to combine my like terms. So my answer for 66 is just going to be 14. 7i minus 8i is minus I. And don't forget your label, ohms. Lastly, I have my resistor for, now this one, look, this one has 2 capacitors. So it's important to know there's 2 different capacitors. So our resistor is 12, so I'm going to start with 12. Then I find my inductor. See, look, they even changed up the order a little bit. They made it a little bit different. Is 8, so remember we make it 8i. Now, to do my capacitor, I have 6 and 10, so it becomes minus 6i minus 10i. Now I combine all my like terms, so I have my best answer for this one is going to be 12. 8i minus 6i is 2i minus 10i is minus 8i. And don't forget your label, ohms. So 12 minus 8i ohms. And that's it for this section. It's a little bit longer video for Firestarter. There is a keyword, so if you didn't listen to it, find it. But it does go over your entire part 2 of your 1.6 homework that a lot of us have not completed.